Show you a set of dynamic AutoWorks turbos that failed, and we'll see what happened to them and how to fix them permanently. These had a thrust bearing failure, so watch this movement. These thrust bearings went bad, and one thing that's interesting is it looks like they had been rebuilt before. You can see it looks like it's been blasted here, so they didn't last very long. I'm guessing that maybe that these do not have the upgraded thrust bearing in those. This guy, I've sold him thrust bearings before in the past. He used to buy a bunch of them from me that were upgraded. Another thing that I noticed, like I went on his website a couple years ago, I don't know if things have changed, but the thrust bearing upgrade is an option that's like $300 that you're supposed to pay extra for the thrust bearing upgrade. The reason why you need that is because if you don't pay for that, then you can never run like over 22 pounds of PSI on these, which doesn't make sense to upgrade the turbos if you're not going to upgrade the thrust bearings anyway. I always thought that was kind of a terrible business model, because if I'm warranting a set of turbos, I would want to make sure that they don't fail because I didn't upgrade the thrust bearing. I don't know, that's just a terrible business model in my opinion. But we'll see. I mean, maybe I'm wrong about this. Maybe these bearings failed for a different reason, but I'm thinking that they failed because they are not the upgraded thrust bearings and not the upgraded collar and spacer. This is why it's so important to use those parts. Also, you know, I made the video on machining the bearing housing for the spacer. That's another important thing that needs to be done. I'll check that on these to see if they're already machined for that. This is what it looks like when the thrust bearing fails. It digs into the compressor housing. This one could have been a lot worse. I've seen them worse than that. We don't really have much of a choice other than to just reuse it, because otherwise it'd be really hard to remake this part. Like, I could probably do it, but it would take probably like 6 hours to do that. The exducer tolerance doesn't matter as much as the inducer does. The inducer is super important. Here's the bearing that failed. The reason is because of how small those oil feed holes are. I'll let you compare them to the bearing we use. Here, I'll get a better look. You see how big our feed holes are? Our bearings are drilled in the top, then replugged, so that the holes can be made bigger. This guy used to buy these bearings from us, but then stopped buying them. So I guess this is kind of the result that can happen if you don't pay attention to quality. They're technically upgraded because they have the bigger collar and spacer, and they have 2 oil feed holes in comparison to the factory 1 feed hole. But the issue he ran into was that he didn't pay attention to the hole size. So here's the 14mm spacer. So it was upgraded, but it still failed. And there's the 14mm collar. It didn't fail on that side. It always fails on the inside if it ever fails. Right there. So I'll link in the description for our rebuild kits. This takes a normal TDO4 rebuild kit, but the difference is that it has the different seal for the compressor housing. So I have a special kit put together just for these turbos so that you buy what you need for these. Now the next thing I'm checking is to make sure that we have the proper adjustment here, which we do not, because I already checked this earlier. I took this off to kind of get an idea how it was adjusted. So when I push that down all the way, the flap will still turn. So this should not turn like that, but the reason is because this was not properly adjusted. I'll show you how it was adjusted here. This is me trying to pull it back as far as I can. It needs to be slightly at the middle, but I usually go like 2 turns past the center. This top right here should be slightly above, is the way I always do it, because you don't really have to make them too crazy tight, but it does make sense to make them in the middle because it compensates when the bushing starts to wear out. Anyway, this is the adjustment he has on here. This doesn't make any sense. Anyway, it's not able to hold the flap closed, so your lead can boost out. They're not going to spool up right like that. Also, the flaps are going to rattle too. So this, you know, if you have a new set of these and they're adjusted like that and it's not right, you need to loosen that up and wind that in. And it's possible if the adjustment's so far wrong that this is maxed in all the way, that maybe he couldn't adjust it more. I'll try to check. There's more adjustment out of it. We'll see how far we can go. We're maxed out right there. Let's see if we can get the adjustment we needed. I mean, it's pretty close. At least it's a lot better. So technically it wouldn't adjust as much as we need to. But it would adjust enough to work though. The last longevity wise though, it might be better to have this flap move that way so you can get a little bit more adjustment on there.